Hi, the title of my talk is The Secret to a Healthy Immune System and Longer Life Might Be Fat Metabolism. So imagine your immune system as a team of highly trained bodyguards, always on high alert to fight off infections and disease. But as we age, these bodyguards start to slow down, they become sluggish, less effective, and sometimes they might even disappear. So why does this happen? Well, it's your lucky day, because today I'll show you how a tiny change in fat metabolism, which is how our body uses fats, could be the key to keeping your immune system strong. Indeed, we often think as fats as unhealthy, but in reality, the right types of fats are essential for keeping our cells flexible, functional, and strong. However, as I shown here in panel A, as we age, the balance of fats in our body changes and the membrane of our cells, which should be fluid and dynamic, start becoming stiff and rigid, just like old rubber tires losing their flexibility. And this happens due to an increase in saturated fats and a decline in beneficial unsaturated fats. So to investigate this further, I turned to a powerful tool, a mutant mouse model shown here in panel B, that cannot produce fats properly. And as a result, it ages much faster than its wild-type control. So essentially, it's acting as a time machine for biology. How cool is that? So here I hypothesized that the defect in fat metabolism might be driving immune aging. And to test this, I collected the bone marrow, which is where immune cells are produced, turned it into a soup that can then be analyzed for RNA and protein levels, as well as fats composition. And I discovered something striking. Critical immune cells that are responsible for fighting infections were dramatically lost only in the mutant model, as if their training program had been shut down too soon. And this loss was directly linked to changes in fat metabolism, causing a complete shift in membrane composition and fluidity, ultimately accelerating immune system aging. But I didn't stop here. Indeed, I wanted to see how this finding could be applied to humans. So in panel C, I examined a human bone marrow database spanning from newborn to the elderly, and you won't believe what I saw. The same immune cell population that disappeared in our mutant mouse model was also dramatically reduced in the elderly human population, which is also shown in the light blue slice of the pie chart. So what does this all mean? Well, this study shows that fats help keep our immune system young and strong. And it also suggests that if we can restore the right balance, perhaps through a supplementation diet, we might be able to slow immune aging and stay healthier for longer. So could the secret to a stronger immune system be hidden in the fats we consume? This is the exciting question I'm now working to answer. Thank you for your attention.